On the screen, we have the curve given to you in green color. Now, under this curve, and between 0 and pi by 2, which is along the x-axis, we have a region given to you in blue color. And this region is the area which is under the curve and between 0 and pi by 2. And suppose that you can calculate the area under the curve between 0 and pi by 2. Now, say that you have got the area, and now a new graph is given to you. Say this graph or this curve given to you in red color, and under this curve and above the x-axis there is a region. So the region on the screen given to you in green color, the region under the curve and between 0 and 1 along the x-axis is a region. So this region in green color is a region where if you calculate the area, it will be exactly same as the region shown to you previously which is in blue color. So the area under the curve shown to you, which is in blue color, is actually the integral from 0 to pi by 2 of the function sine x upon 1 plus cos square x with respect to x, where sine x upon 1 plus cos square x is the function or the curve in geometry, and the limits 0 to pi by 2, they are the real numbers along the x-axis, and so therefore the area under the curve and between 0 to pi by 2 is a definite integral shown to you on the screen. So let us solve this definite integral, and when we say solve, means let us find out what is that amount of area under the curve. So we shall solve this by the method of substitution, and let us put cos x equal to t, and by the theory we discussed last time, cos x equal to t will implies minus sine x dx will be equal to dt. And because we have substituted a function cos x equal to t, then the given integrand will be totally changed and we will be getting a new function. And because we are getting a new function, we have to also change the limits. Why do we change the limits from 0 to pi by 2? It is because we will be getting a new graph or a new integrand after we have done the substitution. And so that we get the same amount of area, we have to readjust the limits. We are no longer take 0 to pi by 2, but in this case, we will have to take from 1 to 0 or 0 to 1. It means the same thing. Why? So that the area under the new graph or the new integrand will be exactly same just like the area given to you under the curve which is given to you in the question. So when we put cos x equal to t, the limits will change accordingly like this. When x is equal to 0, that means there's 0 from the definite integral as given in the question. So will implies that t will be equal to 1. Now when x is equal to pi by 2, and this pi by 2 is a limit given to you in a definite integral as in the question. So will implies that when x is equal to pi by 2 will implies that t is equal to 0. Therefore now the integral from 0 to pi by 2 of sine x upon 1 plus cos square x dx will be changed. The integral will be changed and the limits also will be changed. So the limits from 0 to pi by 2 will be changed to 1 to 0, and sine x dx will be changed to minus dt, and 1 plus cos square x will be changed to 1 plus t square, because we have already put cos x equal to t. Now the integral minus of the integral 1 to 0 can also be written as the integral from 0 to 1, where a formula is there for that. And say we are not changing anything here, we are just keeping the minus sign as it is, then still following the theory of the definite integral and according to the formula I have given to you. So the integral from 1 to 0 dt upon 1 plus t square will be just 1 upon 1 tan inverse t upon 1, and the limits from 1 to 0 given written at the bottom right and the upper right of the two rectangular brackets. So after we have done that, we get the value is equal to pi by 4, and this pi by 4 is nothing but the amount of the area which is under the curve of the integrand sine x upon 1 plus cos square x. So this is about definite integral, and why do we change the limits when we do the substitutions. So remember, the area given to you in green color is actually the integral from 1 to 0 or 0 to 1 of 1 upon 1 plus t square with respect to t. So I hope by now you are clear of what we are doing here while we are changing the limits.